That's the fourth question on the last homework, which is going to be in the exam. Okay, so the Morse circle is given to you. Assume sigma equals 15.1, where sigma is shown here. Indicate the normal stress, sigma x, sigma y, and shear stress, tau xy, including the directions on a thin plane element, like the one shown for problem 1 in this homework. So that is drawn on the right side. This is A, this is B. Okay, so the answer, well, for a problem like this, I don't recommend really using the equations. It's much easier just solving using the Bose circle. So first thing we notice is that well, sigma is 15.1. And then it's given, the shear stress here is given to you. It's half of 15.1, which is 7.05, which is going to be the maximum shear stress.
How good is 7.55?
Oh, my bad. 55 is right, not 0.5. Okay, so that's known. Now the question is, how do you find sigma y and tau xy? The way the circle is connected to the right side, and I don't know if some of you notice this, that there's A and B. A is this point, B is that point. Okay, that's the critical information you need to figure out what the stress is going to be. So clearly the stress at face A is sigma comma 0. So it's clear that A, which is this face, is going to have a stress of sigma, which is 15.1. Okay, and the sign there is positive because it's on the positive x-axis, so it has to be the way it is shown here. Sigma y, on the other hand, which is the stress on face B, is going to be 0. Okay, and then the question is, what is the shear stress on face A? It's going to be the stress, the second component of the stress is this one. That's tau xy. It is 0, so that is 0. So your stress element would look something like this. Hold on. Did I? Shouldn't be inward, right? Okay. Let me check the solution.
I have it right here.
Yeah, I'll see it here. Okay. Okay, that solution is not doesn't correspond to this figure. Then this is what I get. 7.55. Yeah, so I need to fix the solution then. Yeah, solution is wrong. Right, it is wrong. Is there, if everybody agrees with me, or? Yeah, so the solution is incorrect. My bad. I didn't really check the solution in detail. It's really a conceptual question. There's nothing to nothing to really calculate unless once you understand Morse circle. That's about it. So I'll fix the solution. So this is the correct solution.
That's the shear stuff on that square.
It won't be there, right? There's no shear stress on face A because 0. y-axis.
Oh, so the way that it's 7.55 on this.
Yeah, so if you want to draw now, if you want to draw, this is A prime, B prime, right? And then if you want to draw what if I tell you to draw the the element when for face A and B, then what you need to do is you got to see that that's turned counterclockwise by 90 degrees. So this is 90. So anything on this element is going to be 45 degrees, half of that. So 45.
Okay.
And now what will happen is there is a normal stress of 7.55 and a shear stress of 7.55. So that will look something like this. So let's see. Sigma.
You just have to move there's like a 7.55 shear stress on the solution. And I didn't know if that was also something that was correct.
Which one?
Oh,
Just tell me which question.
on the question that we're on right now. Okay. It has like 7.55 MPa. It has a shear like stress.
Right, there's no shear stress. This is the correct solution here. There's no shear stress.
Okay, then and like we got that tau equals like 0, the shear stress equals 0 from the y value of u over at A.
Y value, yeah, that's right. So
But by that logic, wouldn't that mean that almost every one of these would be like 0 in these questions? Because in like the formulas that you gave for the center, you gave something for like the x value, which is one of the like normal stress, like one plus or minus normal stress 2 divided by 2.
right. So no, it will not always be 0, because what happens is, for a generic case, so the question is, will this 0 implies that all this case will have 0? No, because most times when you talk about normal stress, the element A is, the face is normally not on the x-axis, it's somewhere
so
inclined.
Dependent on where A and B are.
Right, this is sigma x, tau x, y.
And A and B will always like be like directly on the x-axis like they are here.
Right.
Okay.
That's how. So this is a more generic case. So I was doing this. So sigma divided by 2 is the stress, as we see here. That's on A, and B is going to have sigma divided by 2. So I drew it here. So this is face P prime, A prime. And then the question is, what's the shear stress? Okay, so what we see here is that the shear stress is sigma divided by 2. But remember that anything on the Mohr circle, which is positive, is negative on the element. And so you need to draw a shear force of sigma divided by 2 on face A prime. So negative shear stress is clockwise. So what we need to do is draw it this way.
Whatever is positive on the circle is negative on the square.
Shear stress, not everything, just the shear stress. Let's draw this. And then on B, you see it's negative, which means it will be going to be positive on face B, which means it will turn the element counterclockwise. So B. So this is to finish it. This will also be sigma divided by 2. Yeah, so if so, one question is this question. This is actual homework 4, Q4. That's the diagram. The other question I could potentially give you is, I could give you A prime, B prime, for example, and then this would be the corresponding answer for that. I could also call that A, B. It doesn't really, the names doesn't really matter, right?
Just scroll down.
Any questions? Okay, so I'll just post this as a separate video in homework 4, so you can watch it, or you can refer this. Okay, any other question? Okay, so let's just move on. By the way, any other question about the exam?
So the exam would just be like up to either Monday or Wednesday. Because you said like everything up to like homework 4, including the lectures, or would that include like something today?
Okay, so I need to be very clear about this. I don't want you to over study for this. So look at homework 1 through homework 4. Okay, and then do related lecture content.
So up to Monday, because that's when.
I think that's why I stopped. Yeah. So just go by the homeworks. Let's see what does the homework cover. I think what I cover is uh, 310 or 3. Let me just get this right. The normal stress is not part of the exam. Okay, it's only the, I think, till 3.9. Yeah, up till 3.9. Okay, so the TA told me that many of you had, and people who are watching on Zoom, the TA told me that